Uh, Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter uh, Basic Principles of Organic Chemistry. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos or in any other chapter of chemistry. If you have more difficulty, then please mention the name of that chapter also in the comments section, so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that match the list 1 with list 2 in the following. So caprolactam, caprolactam is actually like this. Um, 2, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, and each. Okay. So here, okay. So it is like this actually. So this is called caprolactam, which is a so it is a 7-membered ring where one nitrogen is there in the ring, and remaining there are 6 carbon atoms. So it means that one will match with D. And vinyl chloride means it is like this. This one is called vinyl chloride. So vinyl chloride is the monomer of poly uh, polyvinyl chloride, which has been shown here. So 2 will match with C. Then styrene. Styrene is CH2 double bond CH. Then here we have a benzene ring. So this is called styrene. So it is the monomer of polystyrene. It is the monomer of polystyrene which has been shown in the in B option. So 3 matches with B. And propene propene is like this, CH2 double bond CH CH3. This is called propene. So propene is the monomer of polypropene, which has been shown here in the option A. So 4 matches with A. So it means that 1 matches with D, 2 matches with C, and 3 matches with B, and 4 matches with A. So option B is the correct answer. Okay. Then here it is told the set which represents aromatic species is. So in aromatic species, the rule is that it should contain odd number of pi electron pairs. So the number of pi electron pairs should be odd. The number of pi electron pairs should be odd, which is called as the Huckel's rule. Huckel's rule for aromaticity. Huckel's rule for aromaticity. So um, in the first one, here we have three pi electron pairs, since we have three double bonds. So three pi electron pairs we are having. So yes, it is an aromatic compound. It is an aromatic compound. And in the second one, which is called naphthalene, the first one is called the benzene, second one is called naphthalene. So it also has 1, 2, 3, 4, 5, 5 pi electron pairs. So here also there is odd number of pi electron pairs. So this one is also aromatic compound. In the third one it has got 2 pi electron pairs, which is not odd. So it is aromatic, not aromatic compound. And the fourth one also has got 1, 2, 3, 3 pi electron pairs. Since the negative charge which is formed here, it can undergo resonance with these two pi electron pairs. So it has 3 pi electron pairs. So it is also aromatic. It's also aromatic. And the fifth one, it has 4 pi electron pairs, which is not odd, which is an even number. So it is not aromatic. So it means that only 1, 2, and 1, 2, and 4 are aromatic species. So it means option B is the correct answer. Option B is the correct answer. Then here it is told the hybridization change involved at C1 in the above reaction in the carbon number 1. So CH3 links with CH, double bond CH, bond CH to OH. And so here the first carbon is here 1, 2, 3, 4. So here in this case, in the first carbon, it is linked with two hydrogen atoms and one alcohol group. So it is linked with two hydrogens and one OH group. So it has got three bond pairs. It is linked with three bond pairs. So here carbon is sp3 hybridized. So the hybridization is sp3. And in the case of, and in the pro product which is formed, so sp3 hybridization is in the reactant, and in the product it is CHO group. So the C1 carbon, the first carbon will be here 1, 2, 3, 4. So here it is linked with three groups. So it is sp2 hybridized. So the hybridization is sp2 here. So it means the hybridization change involved at C1 is sp3 to sp2. So option D is the correct answer. Then it is told geometrical isomerism is shown by. So geometrical isomerism or configurational isomerism will be shown when we have carbon-carbon double bond. When we have carbon-carbon double bond, or we have cyclic ring compound. So since why when we have a ring or we have a double bond, then uh, we we have rigidity of rotation. Okay, so if here two similar groups are attached and here two different groups are attached, so then here it will be cis, and if two similar groups are on the opposite side, then it will be called uh, trans. So a cis isomer and a trans isomer can be formed in the case of geometrical isomerism. So option 3 is the correct answer. Here in the option 3 only, across carbon carbon double bond only we can have geometrical isomerism. Then according to bare strain theory, which is highly stable? So according to Bayer's strain theory, the rule is, according to Bayer's strain theory, if the if the bond angle, if the internal bond angle, if the intern or I can say if the bond angle in the interior of the ring, in the interior of the ring in case of cyclic compounds is close to 109.5 degrees, which happens in the case of tetrahedral geometry, which happens in the case of tetrahedral geometry, then only we can say that um, that cyclic compound will be more stable. Then only that cyclic compound, then only that cyclic compound is more stable. So in the Bayer's strain theory, if the bond angle in the interior of the ring is close to 109.5 degrees, then only that cyclic compound is more stable. So in case of cyclopentane, in cyclopentane, the internal angle, that is 108 degrees. And in case of cyclohexane, the internal angle is 120 degrees. And in cycloheptane, the bond angle will be um, 180 minus 360 by 7. So which will be even more than 120 degrees. And in cyclobutane, the bond angle is 90 degrees. So it means that in cyclopentane only, the internal bond angle, that is close to 109.5 degrees. So cyclopentane is the most stable according to the Beer strain theory. So option 3 is the correct answer. So cyclopentane is the most stable according to the Beer strain theory. The amino acid which is not optically active is, so here glycine. So for glycine, the structure will be yeah. For glycine, the structure is CH2, then NH2, then COH. This is called glycine. So here on this carbon, we have two similar groups, which is hydrogen, and here NH2 and here COH. So here we don't have a chiral carbon. So for being optically active, the amino acid or any organic compound, we should have a chiral center or a chiral carbon we should have. But chiral carbon, it means it is that carbon which is linked to four different groups. Here, this carbon is linked to two similar groups and two different groups. So here all four groups are not different. So it is not a chiral carbon. So here we have, here there is no chiral carbon. Here there is no chiral carbon. So it is not optically active. It is not optically active. Then a- alanine. Alanine is alanine structure is like this CH, NH2, CH3, and COH. So here in this carbon, uh, four different groups are attached. Four different groups are attached to this carbon. So here we have a chiral center or a chiral carbon. So yes, it will be optically active. It will be optically active. And in case of serine and lactic acid, serine and lactic acid. So serine structure is like this: CH, then CH2OH, then NH2 and COH. So here also this carbon is linked with four different groups. So here we have the chiral carbon. So yes, it will be also optically active. Will be optically active. And in case of lactic acid, so lactic acid structure is also C, CH3, then OH, and H and COH. So here also we have a chiral carbon since it is attached to four different groups. So here we have a chiral carbon, so it will be also optically active. It will be also optically active. So it means that only glycine is not optically active since it has no four different groups. So here it is asked which is not optically active. So glycine only is the amino acid which is not optically active. So option 1 is the correct answer. Then how many chiral carbon atoms are present in 2,3,4 trichloropentane? So pentane structure is like this. Then 2, 3, 4. So 1, 2, 3, 4, 5. So 2, 3, 4 trichloro. So here we have CH3. This is H. This is H. This is also H. This is H3. Okay. So here, as we can see that this is one chiral center since it is attached to four different alkyl, no, four different groups. This, so here it is attached to one hydrogen. This one is attached to hydrogen. This one is also attached to hydrogen. So here we have one chiral carbon since it is linked with four different groups on its four sides. And here we have no chiral. So this carbon is not chiral since why it is attached to two similar groups on either sides. And this one is again chiral carbon since it is attached to four different groups on its four sides. So here we have two chiral carbons. So option 2 is the correct answer. Then plus I effect is shown by. So NO2, Cl and Br all halogens and nitro group. These are all electron withdrawing groups. These are electron withdrawing groups. So they will show minus I effect. They will show negative inductive effect. And only CH3, which is the methyl group, they will show plus I effect. So option 4 is the correct answer. Then in acetylene molecule, between the carbon atoms, there are So in between the carbon atoms in acetylene molecule, so acetylene is like this, which is also called ethyne. So here we have two pi bonds. We have two pi bonds and one sigma bond. Two pi bonds and one sigma bond. So option 3 is the correct answer. The general formula of a cycloalkane is, so the general formula of cycloalkane is CnH2n, CnH2n only, since it is a cycloalkane. Since when one ring is formed, then two hydrogens are removed from an alkane. So if we have only alkane, which is not a cycloalkane, then the general formula should be CnH2n plus 2. But since it is a cycloalkane, since one ring has been formed, so it has the degree of unsaturation is 1 here. Uh, so two hydrogens should be removed from here. So it will be CnH2n. So option 3 is the correct answer. And which one of the following shows functional isomerism? So it will be C2H5OH. So C2H5OH, it can show functional isomerism. How? W- One structure is CH3, CH2, and OH. And one more structure can be CH3O, CH3. It means that one alcohol and one ether can be formed. And so they both will have the uh, same molecular formula, which is C2H6O. But the functional groups are not the same. So alcohol group is not same as the ether group, so they are functional isomers. These two, which one is the ethanol and one is the um, methoxymethane, methoxymethane. So these two are functional isomers. So option 2 is the correct answer. Then which of the following following compound is expected to be optically active? So as we know that showing for being optically active, for being optically active, the compound should have a chiral carbon. The compound should have, the compound needs to have a chiral carbon. Needs to have a chiral carbon, or I can say a chiral center. A chiral center it should have. Chiral center it should have. It, so chiral carbon, it means that that carbon should be attached to four different groups. It means that it should be attached, it should be bonded with four different groups. Then only it will be a chiral carbon. And then only that compound will be optically active. Suppose, for example, in the in the first option, we have two CH3 groups, which is attached to the same carbon, and one CHO group. So here two similar groups, so it is not optically active. And in the second one, it is CH2, and this is CH3, then this is CH2, and this is CHO. So this carbon is also not optically active since it is attached to two similar groups, and this carbon is also not optically active since it is also attached to two hydrogens. So it means it has no chiral carbons, so it is not optically active. And in the third case, it is CHBr, and then this is CH2, then CH3, then this is CHO. So it means here this carbon is attached to four different groups, so it is optically active. Since this carbon is attached to four different groups, so it is the chiral carbon, so it is optically active. Then in the fourth one, it is CHCBr2. So this carbon is linked with two bromine atoms, and here we have CH2, and this is CH3, and this is CHO. So here also we have two similar groups, so it is not a chiral carbon, so it is not a chiral compound also, so it is not optically active. So only the third option, in the third option we have chiral carbon, so it is optically active. So it is optically active, and so option 3 is the correct answer. Then it is told that which cycloalkane has the lowest heat of combustion per CH2 group. Now, according to the Beer strain theory, as we know, that cyclopentane is the most stable, and simply the rule is that if the uh, cyclic if the cyclic compound is more stable, then it will also have higher heat of combustion per CH2 group So it means that cyclopentane is the most stable according to the Beer strain theory, since its bond angle for cyclopentane, the bond angle, the internal bond angle is 108 degrees, which is very close to 109.9 degrees. So it is the most stable cycloalkane according to the Beer strain theory. So it has the least strain. So cyclopentane is the most stable cyclic compound. So for cyclopentane only, it will have the highest value of heat of combustion per CH2 group. Highest value of heat of combustion it will have per CH2 group. But in case of cyclopropane, the internal bond angle is 60 degrees only, and for cyclohexane the internal bond angle is 120 degrees, and for cyclobutane the internal bond angle is 90 degrees. So now in cyclohexane the angle strain will be the highest, so cyclohexane is the least stable. Cyclohexane is the least stable. Cyclohexane is least stable since it has very high angle strain. So for cyclohexane only, it will have the lowest heat of combustion per CH2 group. So cyclohexane only will have the lowest heat of combustion, per CH2 group. Then it is told the basicity of aniline is less than that of cyclohexylamine. This is due to the basicity of aniline. Aniline means which is one benzene ring with the amine group NH2, and cyclohexylamine is it is like this. So it is told the cyclohexylamine this one is more more basic than aniline. Aniline is less basic than cyclohexylamine. This one is cyclohexylamine, and this one is aniline. So this one is more basic than this one. So why it is so? Since why here the lone pair on nitrogen, i- it can it can also take part in the resonance with with the benzene ring. Here the benzene ring, which has got three pi bonds, so it can undergo resonance with the ring. And here, so it means this lone pair is not so much a- available. Since here they are saying that actually cyclohexylamine, it has one lone pair on nitrogen which can be easily supplied. So it is acting as a more stronger Lewis base. Lewis base, it means that which can give lone pair of electrons, which can give or which can donate lone pair of electrons. So here this lone pair of NH2 in cyclohexylamine, it is more a- available since it is not taking part in any kind of resonance. Here resonance is not happening, but in the case of aniline, the lone pair on the nitrogen atom, it is taking part in resonance. It is taking part in resonance with the benzene ring. So it means that the NH2 in the aniline, it will have plus R effect, plus R effect. So it means, so the lone pair is less available. So the lone pair of nitrogen is less available here. On the other hand, in case of cyclohexylamine, the lone pair on nitrogen is more available since it is not taking part in the plus R effect. So this lone pair is more available, so it can more easily give this lone pair. And here in the case of aniline, it can't easily give this lone pair to some other compounds. So simply the reason is that plus R effect of the NH2 group in the case of aniline. Plus R effect of NH2 in aniline is there, and in cyclohexylamine there is no plus R effect. So option 1 is the correct answer. And here it is told inductive effect involves. So in case of inductive effect, there is displacement of sigma electrons. There is displacement of sigma electrons. For example, when if we have a 3 carbon ring and here chlorine is attached to one end. So the chlorine will have minus I effect since it is an electron withdrawing group, since it is electronegative, it is more electronegative than carbon. So throughout these sigma bonds, it will attract the sigma electrons towards itself, and it will result in the polarity. So it will cause a polarity in the sigma bonds. So this inductive effect, it means there is a displacement of sigma electrons. So option 1 is the correct answer. Then it is told which of the following can participate in linkage isomerism. linkage isomerism. So here NO2 can take part in linkage isomerism. For example, so the answer will be option 1 only, since NO2 can take part, the rule is NO2 can take part in linkage isomerism, which happens in the case of D block elements. For example, in this compound, which is called pentaamine, pentaamine nitro, pentaamine nitrito cobalt, pentaamine nitrito cobalt 3 ion. So here we have CO and NH3 whole NH3 whole 5 and ONO, and we have 2 plus. So it means this NO2 can link with the oxygen atom also. So if it links with the oxygen atom, then this ONO is called as the nitrito group, or it can link in the form of nitro also, when nitrogen will link with the cobalt ion, then it will form pentaamine pentaamine nitro cobalt 3 ion, which will be like this: CO NH3 whole 5 NO2 2 plus. So when nitrogen will link with the cobalt, then it will form nitro, and when oxygen will link with the cobalt, then it is called nitrito. So option 1 is the correct answer here. Then here it is told ethyl chloride on heating with AgCN forms a compound X. The functional isomer of X is. So ethyl chloride is C2H5Cl. So when that reacts with AgCN, then isocyanide will be formed, which is C2H5NC, which is ethyl isocyanide. Isocyanide, it means that it is the carbon chain is linked with nitrogen, which is the NC. NC is called as the isocyanide group. So ethyl isocyanide will be formed, which is X. So we have to find a functional isomer of X, which will be C2H5Cn. So C2H5Cn is a functional isomer of C2H5NC, since Cn means it is the cyanide group and NC means isocyanide group. So it is ethyl cyanide, or I can say uh, ethyl cyanide, or I can say ethane nitrile. Ethane nitrile will be formed. So which is a functional isomer of X. So option 3 is the correct answer. Then here it is told a compound containing only carbon, hydrogen and oxygen has a molecular weight of 44. It has a so it contains carbon, hydrogen and oxygen only. It has a molecular weight of 44. On complete oxidation, it is converted into a compound of molecular weight 60. The original compound is. So when it is oxidized, let's say the compound X is oxidized, it means uh, suppose KMNO4 and or nascent oxygen is used, then it is oxidized to Y. Mm, now its molecular weight is 44 and its the molecular weight of Y is 60. Then we have to find the original compound, which is X. This compound we have to find. So it is oxidized to compound having molecular weight 60. So now the increase in the molecular weight, increase in the molecular weight, that is equal to 60 minus 44, that is equal to 16. So 16, as we know, it is the atomic mass. It is the atomic mass of oxygen. So therefore it means one oxygen will be added. Oxygen is added. So now it means that mm, when oxygen is added, it means that the original compound should be an aldehyde. It should be in the form of RCHO, and it is oxidized to RCOH. Since why in this case only, when an aldehyde is oxidized to a carboxylic acid, then only there is an increase in the molecular weight by 16, since one oxygen will be added here. And it has this molecule X, it has molecular weight 44. So now CHOs, so for carbon it is 12, hydrogen it is 1 plus 16, so that is 6 plus 3, 9, so 39. And 44 minus 39, so that will be equal to 5. No, sorry. This is this will be 29. 13. So 44 minus 29 is 15. So 15, it means that it should have one CH3 group. One CH3 group should be there. Since why carbon is 12 and 3 hydrogens, so 3, that will be 15. So the mass of one CH3 group, one alkyl group is 15. So here it means the aldehyde is actually, the aldehyde should be actually CH3CHO, CH3CHO, which is called ethanol, and that will be oxidized to form CH3COH, whose molecular weight is 60 and the molecular weight of ethanol is 44. So it is oxidized to ethanoic acid or acetic acid. It means the original compound is an aldehyde. Option 1 is the correct answer. Then it is told to find the name of this carbon compound. So it is CH3 double bond CH, and this is CH3 and here Cl. Okay. So here we can start the start numbering from this end, on the left end, 1, 2, 3, 4, 5. So it will be 2 chloro, 2 chloro and 4 methyl, 2 chloro, 4 methyl and 2 pentene, or I can say pent2ene also. 2 2 chloro 4 methyl pent2ene, or I can say 2 chloro 4 methyl 2 pentene. So option 1 is the correct answer. Then it is told in acetylene molecule, acetylene, or it is called ethyne. So here we have in, so the two carbon atoms are linked by one sigma bond and two pi bonds. So option 3 is the correct answer. Then it is told cumene process is the most important commercial method for the manufacture of phenol. Cumene is, so cumene, it is actually isopropyl benzene. It is like this actually. It is called isopropyl benzene. So isopropyl group, I can write the name like this also, which is, or I can say 1 methyl ethyl, 1 methyl ethyl benzene. So option 3 is the correct answer. So the common name of isopropyl benzene or 1 methyl ethyl benzene is cumene, and which is used for the manufacture of phenol. Phenol is this. Phenol is a benzene ring with one hydroxy group. It is called phenol. So phenol can be obtained from cumene, and which is also used in the commercial process. Okay. Then pick out the alkane which differs from the other members of the group. So the first one is 2-methyl butane. 2-methyl butane, 2-methyl butane, which is like this. It will be 2-methyl butane, the option 1. And second one is 2,2-dimethyl butane. 2,2-dimethyl butane, which is like this. This is 2,2-dimethyl butane, and third one is 2,2-dimethyl propane, which is like this. 2,2-dimethyl propane, 2,2-dimethyl propane. This is, and pentane. It means it is N-pentane. Is CH3, CH2, 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 CH3. So this is called pentane. So here it has 5 carbon atoms. Here also it has 5 carbon atoms. Here also it has 4 plus 4, 5, 6. It has 6 carbon atoms. And here also it has 5 carbon atoms. So it means that this 1, 3, and 4, these are chain isomers. They are chain isomers since the length of their chain is not same. Only the second one is not an isomer of pentane. Since the third one is also called neopentane, and the first one is also called isopentane. So isopentane and N-pentane and neopentane, they are isomers. They are chain isomers, and only this, it has 6 carbons, so it is not an isomer of these three. So option 2, it is a different uh, compound. Then yeah, so the second one, it is different from the other three members of the group. So option 2 is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter Basic Principles of Organic Chemistry. Still, any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And also please install our Sapience education application, where we shall upload some important previous year questions based on the KCT exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.